Our solar system. For thousands of years, humanity believed every solar system looked like ours. 1 star. 8 planets. Everything moving in calm, predictable orbit. It seemed like the universe had found the perfect design. But that assumption lasted only until we began discovering planets around other stars. What we found wasn't another solar system. It was something far stranger. Some systems have 2 suns. Others have 3. Some contain giant planets orbiting so close to their stars that a single year lasts only a few days. Others don't even have a star at all. It turns out our solar system isn't the standard. It may actually be one of the unusual ones, and the first discovery completely changed what astronomers thought was possible. Binary star systems. Imagine standing on a planet where 2 suns rise into the sky. As one climbs above the horizon, another slowly follows behind it. The landscape is covered by 2 shadows instead of 1. Sunsets happen twice. Sometimes daylight lasts much longer than it does on Earth. Other times, darkness arrives in strange and unpredictable ways. For centuries, scientists believed planets couldn't survive in a system like this. The gravity of 2 stars seemed too unstable. Any planet caught between them should eventually be thrown into deep space. Then astronomers looked closer. They found entire worlds peacefully orbiting 2 stars at once. These are called circumbinary planets. Instead of circling a single sun, they orbit both stars together as if they were one giant object. Other binary systems work differently. The planet circles only 1 star while the second star remains much farther away, shining like an incredibly bright neighboring sun. Nearly half of all sun-like stars belong to binary systems. That means 2 suns may be just as common as 1. The universe wasn't breaking its own rules. We simply didn't know the rules were this flexible. But if 2 stars seem complicated, the next systems don't stop there. Some contain 3. Or even 4. Multi-star systems. If 2 suns sound complicated, imagine living beneath 3. Or 4. Astronomers have discovered planetary systems containing multiple stars bound together by gravity, creating some of the most chaotic environments in the galaxy. On these worlds, the sky is never the same twice. 1 star may be setting while another rises. A third might appear only during certain seasons, turning night into daylight without warning. Gravity becomes a constantly shifting puzzle. Every star pulls on every other star, forcing planets to follow incredibly delicate paths through space. At first, scientists thought these systems would be too unstable for planets to survive. Yet observations proved otherwise. Some planets have remained in stable orbits for billions of years, carefully navigating a gravitational dance that looks almost impossible. It reminds us that nature is far better at solving problems than we are. But while these planets have too many stars, the next systems have the opposite problem. Their planets are far too close to just one. Hot Jupiter systems. When astronomers discovered the first planet around another sun-like star in 1995, they thought their instruments were broken. The planet was enormous, almost the size of Jupiter, but instead of orbiting far from its star, it was practically touching it. 1 year lasted just over 4 Earth days. Temperatures climbed beyond 1,500 degrees Celsius. Clouds of vaporized metal drifted through the atmosphere. Some of these planets are slowly being torn apart by their own stars, leaving giant trails of escaping gas behind them. Nothing like this exists in our solar system. Before this discovery, scientists believed giant planets could only form far from their stars. Hot Jupiters proved that planets can migrate across entire solar systems long after they're born. Completely changed our understanding of planetary formation. But even these worlds have plenty of room between them. The next systems pack entire families of planets into spaces smaller than Mercury's orbit. Compact planetary systems. Imagine fitting nearly an entire solar system inside the orbit of Mercury. It sounds impossible, yet that's exactly what astronomers found. The TRAPPIST-1 system contains 7 Earth-sized planets orbiting a small red star. Every one of them lies closer to its star than Mercury does to the Sun. If TRAPPIST-1 replaced our solar system, all 7 planets would fit comfortably inside the orbit of our innermost planet. From the surface of one world, neighboring planets would appear enormous in the sky. Some would look larger than our moon. Gravity links these planets together in an almost perfect rhythm. As one completes several orbits, another completes exactly 2, then another completes 3. Like gears inside a clock, The entire system moves with incredible precision. But even these tightly packed worlds still have something in common with ours. They orbit a star. The next planets don't orbit anything at all. Rogue planet systems. For centuries, astronomers believed every planet needed a star. After all, without a star, there would be no light, no warmth, no energy, no reason for a planet to exist. Then they discovered something wandering through the darkness, completely alone. These are called rogue planets, worlds that drift through interstellar space with no sun to orbit. Some were likely born inside ordinary solar systems before a close encounter with another giant planet violently threw them into deep space. Others may have formed entirely on their own, collapsing directly from clouds of gas without ever becoming stars. Imagine standing on one. There is no sunrise, no sunset, no blue sky. Only an endless black horizon filled with distant stars that never grow brighter. The surface would be unimaginably cold, with temperatures falling below -200 degrees Celsius. Yet scientists believe some rogue planets could still hide liquid oceans beneath thick layers of ice, warmed only by the heat trapped deep inside the planet itself. Life, if it exists there, would never know what a sun looks like. But even these lonely worlds still orbit something. The next planets circle one of the deadliest objects in the universe: pulsar planet systems. Most stars spend billions of years quietly burning hydrogen. Eventually, some die peacefully, others explode. When a massive star ends its life in a supernova, the core can collapse into a pulsar, an object barely 20 kilometers wide, yet heavier than our sun. It spins at incredible speeds, sending powerful beams of radiation sweeping across space like a cosmic lighthouse. Anything nearby is constantly exposed to lethal energy. For decades, astronomers assumed nothing could survive around a pulsar. Then they discovered planets orbiting one. The first confirmed exoplanets ever found weren't orbiting a normal star. They were orbiting a dead one. If Earth suddenly orbited a pulsar, our atmosphere would quickly disappear. Radiation would sterilize the surface. Our oceans would slowly vanish into space. Yet somehow, entire planetary systems exist in these hostile environments. Whether they survived the original supernova or formed afterward remains one of astronomy's biggest mysteries. It proves that planets can appear in places we once believed were completely impossible. But even a dead star isn't the strangest thing a planet might orbit, because the final type pushes the limits of modern physics itself. Black hole planetary systems. Black holes consume stars. They bend light. They distort time itself. The idea of planets orbiting one sounds impossible, yet according to modern physics, it may actually happen. Astronomers have proposed the existence of planets forming inside the enormous disks of gas surrounding supermassive black holes. These disks contain enough material to build thousands of planets. If one formed there, the sky would look unlike anything in the universe. Instead of a bright sun, a giant black circle would hang overhead, surrounded by a glowing ring of superheated gas moving at millions of kilometers per hour. Gravity would warp the light around it, making distant stars appear bent and distorted. Time itself would pass differently depending on how close the planet orbited. Hours on the planet could correspond to days, or even longer, for a distant observer. No one has confirmed a planet yet, but the mathematics suggests they could exist, and if they do, they would be among the strangest worlds in the universe. The more planets we discover, the less ordinary our own solar system becomes. For centuries, humanity believed there was only one way to build a planetary system: one star, a handful of planets, everything neatly arranged. But the universe had other ideas. It created systems with 2 suns, 3 suns, worlds packed closer together than we thought possible. Planets wandering through the darkness alone, and perhaps even planets orbiting black holes. Every new telescope reveals another exception, another impossible discovery, another reminder that the universe isn't trying to match our expectations. It's showing us just how limited they were. Perhaps the most surprising discovery isn't that these strange solar systems exist. It's that after thousands of years of looking up at the sky, we're only beginning to understand what a solar system can actually be.